In this video, what I intend to do is show you how to factorize polynomials. So previously we've looked at what a polynomial is, and we've also looked at how to do long division. Well, that whole idea of long division will come in very handy when we have to go and turn a very large string of terms into some very lovely brackets. Here I've got a polynomial that says x cubed minus 2x squared minus 5x plus 6. Eventually, I'm going to have to factorize it, but first and foremost, I've asked some seemingly random questions here. What I'm going to do is I'm going to do the left-hand column first and foremost. I need to find the p of 2. So, as we remember, what that means is that I just need to go and replace every x with the number 2. So this is going to be 2 cubed minus 2 squared minus 5 times 2 plus 6. And that will all end up nicely as 8 minus 10 plus 6, which equals to negative 4. And then I've also asked to find p of negative 2. So what that means, of course, is I'm just replacing everything with a negative. Of course, always make sure you're being absolutely careful with all of our very lovely brackets here. Because this is where you can fall into traps if you haven't got your brackets all sorted, especially 2 minuses. And then if we put that all together, we get negative 8 minus 8 plus 10 plus 6, and we get ourselves 0. Okay. Last one here, I've asked to find the p of 1. So p of 1 means that I'm just going to replace all of the x's up in here with the number 1. So that's going to be equal to 1 cubed minus 2, 1 squared minus 5, 1 plus 6, which gets us 1 take away 2, take away 5 plus 6, which also gets us a 0. So just something for us to remember there, that negative 2, 1, and then 2. If I replaced all the x's with a 2, we got the answer of negative 4. If we replaced all the x's with a negative 2, we got a 0. And if we replaced all the x's with the 1, we got a 0. So what I'm going to do is I'm now going to do some long division. I might just keep that like so. It's always good to get our practice up with a long division. So again, we want to divide x cubed divided by x is going to be x squared, and that times or multiplies in x squared times by x is going to get us x cubed. X squared times by negative 2 is going to make that negative 2x squared. Oh, and we're going to get some subtractions out for just a moment. So that's then going to become negative 5x, because those x cubed take away x cubed is 0, negative 2x squared minus 2x squared is going to be 0. So we're going to bring that 5x down, and we're going to bring out the plus 6 down as well. You'll see why I've done this in a minute. So x divided by negative 5x is going to make that minus 5. And then we'll multiply that. Negative 5 times x is negative 5x. Negative 5 times by negative 2 is going to make that positive 10. 5x take away, negative 5x take away negative 5x is 0. 6 take away 10 is equal to negative 4. So our answer is x squared minus 5, remainder negative 4. Now that's interesting. If I substituted a 2 into the polynomial, I got the answer of negative 4. If I divided this polynomial by x minus 2, I got a remainder of negative 4. Interesting. Let's have a look at our next friend here. So I've asked to divide the polynomial by x plus 2. So let's do this. x cubed minus 2x squared minus 5x plus 6x plus 2. And we've got to divide these. So x cubed divided by x is x squared. X squared times by x gets me x cubed. X squared times by positive 2 gets me positive 2x squared. X cubed take away x cubed gets me 0. Negative 2x squared take away 2x squared is going to make that negative 4x squared minus 5x. Negative 4x squared divided by x is negative 4x. We multiply this, friend. Negative 4x times by x gets us negative 4x squared. Negative 4x times by 2 gets me negative, I was about to say negative 10. Silly me. It's because my brain fell out. Negative 4x times by positive 2 is negative 8x. Negative 4x squared minus 4x minus negative 4x squared is going to get us 0. Negative 5x minus negative 8x, so again a minus, it's going to give us a 3x. Bring that 6 down. X goes into 3x plus 3 times. And the positive 3 times by x is 3x. Positive 3 times by positive 2 gets us positive 6. We minus these, friends. 3x take away 3x is 0. 6 take away 6 is 0. Huzzah! So, we found that our answer here is x squared minus 4x plus 3. And it has no remainder. So interestingly, when I substituted negative 2, I got 0. When I divided by x plus 2, I got a remainder of 0. When I substituted with just plain ordinary positive vanilla, if you like, positive 2, I got an answer of negative 4. And when I divided by x minus 2, I got a remainder of negative 4. So I wonder if we can develop a pattern developing here, or we can see a pattern here. Also, I wonder if it's jolly good that we've managed to get ourselves a lovely no remainder here. So again, keeping my practice up. Minus 5x plus 6. And this time I'm divided by x minus 1, knowing quite well that by substituting x is for 1, I managed to get an answer of 0. So I wonder what the remainder is going to be this time. X cubed divided by x is x squared. And then we multiply that through. X squared times by x is x cubed. X squared times by negative 1 is negative x squared. X cubed take away x cubed is 0. Negative 2x squared minus x squared makes that negative x squared. We can bring down that 5x there. And then we're going to go and divide this nonsense here. So negative x squared divided by x is going to be negative x. We're going to multiply that, friend, so that we didn't derp. Marvelous. Negative x times by negative 1 makes that a positive x. If you've forgotten what I'm actually multiplying, I'm multiplying the two values in this divisor. So when I did that multiplication, I'm going from here and I'm multiplying those as well. So, negative x squared minus negative x squared, 0. Negative 5x minus x is going to make that negative 6x. Bring this plus 6 down. And then we're going to divide this, friend. Negative 6x divided by x gets me negative 6. Negative 6 times by x is negative 6x. Negative 6 times by negative 1 is me positive 6. And huzzah, we have got no remainder. So my answer here is x squared minus x minus 6. So that's an interesting set of things that we've discovered here. We've been able to divide these polynomials, and there has been some sort of pattern. And the pattern it goes like this. It's referred to as the remainder theorem and also the factor theorem. So the remainder theorem, which we can might just jot up here for our benefit. So the remainder theorem that if I've got some polynomial x, or some polynomial, and I divide it by some factor of x minus a, for example, so where a is some number, the remainder will equal the same thing if I substituted all the x's with the letter a, or whatever value a happens to be. This leads us quite nicely into the factor theorem. That if I have p of a equals 0, then x minus a is a factor. So what that means is if I was to divide the polynomial by that particular brackety thing, and I got, and that will mean that there would be no remainder, and it would be a factor. In other words, that would be one of the little things I can turn the big polynomial into a set of brackets. Remember how, like with quadratics, we wanted to get them into two sets of brackets, or maybe one with a little squared outside. This is the same sort of thing, that we're trying to turn cubics into lovely sets of brackets, or alternatively quartics or any other large polynomial. So this second one here, where we had a no remainder, we can actually factorize this, friend. So if we, let's get a different color actually, let's find what was one we haven't used. We haven't used the dark blue. So factorized form. So my original is x cubed minus 2x squared minus 5x plus 6. We know that if I divide it by x plus 2, I'll get no remainders, so that's going to be a factor. And the answer up here, the answer that we got, well, that's another factor. Because what does factor mean? Factor is, or if I had two factors of a number, it means if I multiply them together, that will create that answer. Now, can we turn this quadratic into two smaller brackets? Well, yes, we can. Because what's two numbers that multiply together to get positive 3, add together to get negative 4? Well, that's going to be x minus 3, x minus 1. So there we go. Fantastic. So we can now use this knowledge to factorize. So how did I get the factorized form? I took the thing that we divided by. I took the answer up there, that little orange answer up here. And then what I did is then I put them in two brackets, and then I went to see if I could break up the answer into two other brackets. Now, it's a thing to think about, from not right now, but in the future. Sometimes you can't break up that second bracket, that big x squared one. Sometimes it's a little bit funny. If you can't break this up, that's okay. Don't panic. Don't, catch on fire. What it just means is that it only has one x-intercept, and there might be some other nonsense going on. Or alternatively, you might find you might have to complete the square. Either way, hopefully you can factorize it. So let's have a look at this, friend. So this one here, we had this lovely answer. So if I want to factorize this, so factorized form, this is x minus 1, x squared minus x minus 6 is the factorized form. Can we do anything with this? Well, we can. Can we get this into two smaller brackets? So I need to think of what's two numbers that multiply together to get negative 6, add together to get negative 1. Well, it's going to be negative 3 and positive 2. There we go. We have factorized that as well. So we have factorized that polynomial into three brackets. Hooray. And this will be useful when we're graphing a cubic, so we can use it to find out, you can use those to find x-intercepts, but we'll worry about that a little bit later.